Stereoisomers. These are the compounds having same structural formula but differ in their spatial configuration. Stereoisomers of carbohydrates are as follows. Epimers. Epimers are those sugars which differ with each other with respect to single carbon atom other than the penultimate carbon atom. Now this is the structure of the glucose, and these are the structures of the mannose and galactose. So mannose is C2 epimer of glucose, and glucose and mannose differ with respect to each other at the second carbon atom. And C4 epimer of glucose is galactose, and these glucose and galactose differ with respect to each other at fourth carbon atom. Now, glucose, mannose, and galactose, they also differ with respect to C2, C3, C4 atoms when all the three are considered together, and these are known as stereomers. So next one is the dextro and the levorotatory carbohydrates. Now this is due to the presence of asymmetric carbon atom. The carbohydrates can rotate the plane polarized light to either right or left. So glucose is a dextrorotatory compound because it rotates the light to right side, whereas fructose is a levorotatory compound because it rotates the plane polarized light to left side. Next is the D and L isomers. Now these are the mirror images formed due to change in the orientation of H and OH group around the penultimate carbon atom. Now all the naturally occurring sugars are capital D. They are written with capital D. They have the OH group on the right side, and the L sugars or the L glucose has the OH group on the left side. Next, another type of stereoisomer is the anomer. So glucose has two anomers around the anomeric carbon atom, which is nothing but the first carbon atom. Now the anomers are formed due to change in the orientation of H and OH group around the first or the anomeric carbon atom. Alpha D glucose has the OH group pointing downwards, and the beta D glucose has the OH group pointing upwards around the first carbon atom or the anomeric carbon atom. Now these alpha and beta D glucose contribute to a property called mutarotation. Now when glucose is crystallized at room temperature, now initially it has got a rotation of plus 112, and when this solution is kept for around 12 to 18 hours, the activity changes to plus 52.5. Now this is because of alpha D glucose. The 112 activity is because of alpha D glucose. And when the glucose is crystallized at 98 degree, initially it shows an activity of plus 19, and when kept for 12 to 18 hours, the activity changes to plus 52.5. Now this plus 19 activity is because of beta D glucose. Now at equilibrium, 1/3 of the molecules exist in alpha D glucopyranose form, and 2/3 of the molecules are present in beta D glucose pyranose form. And you need to remember that glucose oxidase enzyme acts on beta D glucose and not on alpha D glucose. Now this was all about stereoisomers.